All right, welcome back from the break, everyone. And I can see that Richard is lurking in the background as well. At least I saw his name popping up there on the list. Whether he can hear me or not, that's a different story. Hello, Richard.
Hey, how's it going?
Pretty good, sir. How are you?
Very good. Just dealing with a speaker issue there. I couldn't hear anybody for a second, so sorry about that.
Technology, technology.
Yeah,
That's why
too
we still have a job. Yeah.
too many too many choices. That's the problem. It's like, where do you want this sound to go? I can hear it, but it's coming out of my headphones on the floor, so it doesn't help me.
Not really, no, but great to have you back. And
Thank you. Great to be back.
for those of you that haven't met Richard, he is I'll allow him to introduce himself, but put it this way: when Andrew and I started this training back in I guess it was 2022, 2023, the first time we ran it, I always wanted to include the concept of always on VPN, and I figured, how hard can it be? 10 minutes should be enough.
Yeah.
I was wrong.
Yep.
So long story short, I ended up asking Richard, "Hey, would you present this topic to us?" Yeah, it'll take about 2 hours. Like, all right, fantastic. So here we are, three
Good
years
deal.
later, and still doing this together with a health fidelity certificate too.
Yeah, because certificates are a big part of always on VPN, so we'll talk about those as well.
Uh, I, uh, I figured you might, but I won't keep you waiting any longer. As always, it's our privilege to have you back, and the floor is yours.
Very good. Let me get my presentation up here. And then got to find the right screen to share. Give me 1 second.
I have only two screens, and I sometimes struggle. So
Yeah, yeah, exactly. Yep. Let's see here. And what's funny is they're numbered differently in Windows, and then Zoom enumerates them differently. So it's like I know that one over there is number three, but Zoom calls that one number one. So go figure. Good times, good times. Everyone should be able to see my screen now, I hope.
that's good, sir.
Oh, good. And let me also, before we get started here, no, uh, chat. I want to kind of keep an eye on the chat over here. So in case questions come up, just hit me in the chat and I will respond to them. So getting started. Thanks everybody very much for joining me today. Thanks, Johan and team there for including me as always. And for those of you who don't know me, my name is Richard Hicks. I'm the founder and principal consultant here at Richard M. Hicks Consulting. I focus predominantly on two specific areas, secure remote access and digital certificates with PKI, mostly around the Microsoft space. And so I've been consulting, I think, almost 10 or 11 years now independently. And before that, spent a little time in large enterprise networks. I worked for a giant bank at one point. So anyway, in for the next 2 hours, we are going to be talking about always on VPN, specifically managing the client configuration aspects of always on VPN with Intune. So we're not going to really dive deep into infrastructure. You won't learn how to set up the VPN servers or anything like that. We're really going to focus on the Intune management aspects of that because this is an Intune masterclass after all. A bit of housekeeping, just to let you know, my latest book is Implementing Always On VPN by A Press Media. You can learn more there if you go to aovpnbook.com. And a lot of the things that we're going to be talking about, I've written about extensively on my website, on my blog, directaccess.richardhicks.com. And also, I have many, tools, scripts, sample files, all sorts of things available on GitHub. So you can go to github.com/Richard Hicks. I'll probably reference that numerous times throughout the talk for the next couple of hours here. So that's where you can find me and my things, I guess. Also, I want to make sure everybody knows there's a couple of learning opportunities coming up that I think that you'll be interested in. Beginning in January, middle of January next year, I am delivering a PKI fundamentals course here on the Via Monstra Online Academies. This is a 6-week session, so it's 2-hour sessions spread out over 6 weeks, and it's basically kind of an introduction to Microsoft Active Directory certificate services. So, kind of high level, but it should give you a real good foundation to build upon if you're looking to deploy certificate services on premises today, or if you already have ADCS up and running. We're going to cover lots of implementation and security best practices, and we'll talk about those things at length. So I'm sure even if you have ADCS deployed, this will still be valuable for you, and the cost is fantastic. This is a really inexpensive course. So encourage you to sign up there. You can go to richardhicks.com/PKI fundamentals. And then finally, in March, following up on that, we're going to do another certificates masterclass. So this is Mastering Enterprise PKI Certificates with Microsoft Intune. So this is a 3-day deep dive, comprehensive look at all aspects of issuing and managing certificates with Intune, PKCS, SCEP, for all platforms. You can learn more there and register by going to richardhicks.com/masterclass. All right, on to the agenda. I want to just kind of set the stage for what we're going to talk about for the next 2 hours. We got till 4:30 Central, I think. I want to give you kind of a brief introduction overview to Always On VPN, and then talk about some of the options of managing Always On VPN client configuration settings using Intune. Certificates play a big part in Always On VPN. We are using certificates for strong authentication, not only for users, but for devices. And of course, if we're managing our endpoints with Intune, we might also need to deploy certificates to them using Intune, and we'll talk a little bit about that as well. I want to address some of the fine tuning and optimization aspects of deploying Always On VPN. Out of the box, the default settings leave a little bit to be desired, putting it mildly. And there are a number of things that you can do with Intune to address those. I do want to talk a little bit about autopilot. I think you've covered autopilot to this point. I want to talk about some specific scenarios around autopilot and how Always On VPN can help in some scenarios, in some use cases. And then finally, I want to wrap up with just a brief discussion about Microsoft Global Secure Access, or GSA. So GSA is a security service edge solution from Microsoft that is probably going to be the replacement for Always On VPN in the future. Maybe not quite ready for prime time today, but we're getting close. And so I'm going to kind of tease that a little bit, talk about it, maybe answer any questions you might have about it, and go from there. That being said, let's move on with Always On VPN. And again, if you have any questions, pop into the chat. Kevin, thanks already for the work on strong certificate mapping. My pleasure. There was a lot of folks that had some pain with that. I think we'll talk about it a little bit later, but glad you got that sorted out. Anyway, introduction to Always On VPN. Always On VPN, of course, is Microsoft's secure remote access solution. It really was the successor to their very popular direct access solution. So direct access is what we used for modern secure remote access beginning in 2008, I think that was introduced, very widely deployed, really popular, challenging from an administrative perspective because it was a very complex solution, lots of moving parts and intricacies and interdependencies. Always On VPN doesn't have much of those. It's a much simpler solution. So, but much like direct access, Always On VPN provides seamless and transparent secure remote access. When direct access was first introduced, it was kind of a paradigm shift. But before that, Always On, or VPNs weren't always on. They were ad hoc user initiated, and you had to find the VPN connection, launch it, enter your username and password, probably accept an MFA prompt, or put in your PIN if you're using the old RSA tokens and things like that. And I'm speaking from experience here because I lived that for many, many years, right? From the 90s till the mid 2000s, late 2000s or so. But direct access kind of introduced us to this whole, hey, why does this have to require user interaction? Why don't we just do it on their behalf? Connect at the machine level. When the user profile loads, we'll give them a little bit more access, and always on VPN follows that paradigm. So it is seamless, it is transparent, it is automatically connected, and there with always on VPN, much like direct access, you can connect the device and the user. Where direct access you did both, with always on VPN, you can choose one or the other or both. And we'll talk about a little bit about when you might do those later. And again, as I mentioned before, kind of the successor to direct access. Direct access was a great solution, but it was not long for this world when Microsoft got into the cloud business. Um, a lot of folks ask me, well, why was direct access deprecated? It seemed to work very well. The problem was is that it required domain join. Domain join was a requirement for direct access servers and direct access clients. And as you probably are well aware, Microsoft is trying to get everybody to move to the cloud. No sense in propagating a solution that requires a classic Active Directory on premises. So they had to come up with a solution that was direct access like, but that was more cloud supportive. And always on VPN meets that bill. It's a great solution. It integrates, with Azure Entra ID, supports conditional access. You can use native Entra devices and users. So it's a much better solution from a cloud integration aspect than direct access was for sure. Mike, still using direct access. You're a brave man. Direct access is going away, buddy. My friend, it's probably time to, if you're not already planning a migration, hopefully you are soon. Microsoft has deprecated direct access. It will probably not be in the next release of Windows Server. There's no indication as to when they're going to take it out of the client for client support. They've committed to supporting it through the end of Server 2025, but there's some gray area as to whether or not they're gonna support it in Windows 11 or Windows Client vNext. So yeah, so direct access is not long for this world for sure. So but yeah, it works fantastic. So as long as you don't look at it the wrong way. So sometimes it can be a bear to support if you've done any of that. If you ever had any fun, like if an NLS goes down or something like that, good times. Anyway, some important features for always on VPN. As I mentioned before, direct access was domain join required. Always on VPN is domain join optional. Your endpoints do not have to be joined to the domain. So they do support native Entra join. The servers don't even have to be joined to the domain. And in fact, you don't even have to use Windows Server. We'll talk about that in a few minutes. Um, it supports Professional Edition or Enterprise Edition. Direct Access was Enterprise Edition only. Always on VPN supports Pro, but in some use cases, it still requires Enterprise, and that's specifically around hybrid join. If you want to deploy the device tunnel actually requires Enterprise Edition still. So supports modern management, which is of course Intune, but it technically could be managed with any other third-party MDM. I don't spend a lot of time in that space. I think Workspace ONE is the only one I know of. But anyway, in theory, it would support any MDM that supports CSP, and so but we typically do that with Microsoft Intune. Cloud integration, as I'd mentioned before, you can use Entra ID auth. You can integrate it with conditional access. So it has a lot of benefits over and above direct access. Much more deployment flexibility is much greater. Again, cloud adoption is not blocked by domain join requirements and things like that. So it's a much better solution in regards to that, and better fits into Microsoft's cloud story, right? They're interested in getting everybody to their cloud. They have no interest in propagating solutions that have dependencies on classic Active Directory. So direct access had to go away, but direct access was a phenomenal solution. So Microsoft had to come up with something that was similar. They had to come up with a solution that provided those same features and benefits, but yet supported the cloud, and that's always on VPN. Always on VPN is infrastructure independent, and this is very much different than direct access because direct access required Windows Server period, full stop. Always on VPN can be deployed with a variety of solutions on the back end. So most commonly, we do this with Microsoft Windows Server, and we deploy the routing and remote access service, or RAS role, much like we did in direct access. We just configure it a little bit differently. Instead of setting up direct access, we set up the VPN type. And we configure our VPN protocols and go forward from there. However, you can also support always on VPN clients with Azure VPN Gateway and Azure Virtual WAN. Those are options as well. And I say those are options that I should have an asterisk here. There's a caveat in that Azure VPN Gateway and Azure Virtual WAN, basically any other solution other than RAS, always comes with some limitations. Um, and that being that some scenarios aren't always supported due to limitations of the service. For example, Azure VPN Gateway has limited support for SSTP. So if you're doing IKV2, we'll talk about the protocols in a bit. But if you're doing SSTP, there's very limited support for that. And there's no support for SSTP in virtual WAN. So those types of things come into play. You can use non-Microsoft platforms. So you could terminate your always-on VPN connections from Windows 11 or Windows 10. Well, Windows 10's dead, right? Windows 11 clients. I don't have to mention Windows 10 anymore, right? Windows 11 clients, you can terminate those against the security platform of your choice. Almost all of them, especially the popular or the major ones, would support client-based VPN connections using IKV2. So Cisco, Palo Alto, Checkpoint, Juniper SonicWall, Fortinet, you name it, they probably support that. However, again, as I'd mentioned before, there are limitations associated with that. When you use a third-party VPN device, you must use either IKV2 or the plugin provider for VPN. So when you're talking about VPN clients, and let me see if I can pull this up for you here. When you look at VPN clients, let me go to my VPN settings here. So I have some VPN connections, and you'll see that I've got a couple of VPN connections here. These connections use what's known as the native VPN client. You can install third-party software like full standing, like Cisco, like Palo Alto Global Protect, Cisco Secure Connect, all of the other ones, and they're full standalone Win32 apps. But you can also download what's known as a plugin provider, which basically is a third-party software integration with the native client. So if I was going to go to add VPN, the VPN provider here is Windows built-in. But if I select if I pull down from this list, I have other options available to me. So Azure VPN is a plugin provider for Windows. But let's say I was going to deploy Global Protect here. So at this point, I'm using a plugin provider, and so this software comes from Palo Alto, but it's not the full suite of VPN capabilities that their full standalone client has. It's a subset of those. The advantage here is that it integrates with the Windows platform. So Windows does the heavy lifting, they layer their software on top of that. So if you are using a third-party tool or to a platform, like let's say you wanted to terminate against a Cisco router or a firewall, then you would select your Cisco, I have AnyConnect in here, and then I would build out my profile accordingly. Alternatively, I could use the Windows built-in, but then I would have to use the IKV2 protocol. So, those are the limitations associated with building VPN connections with third-party VPN devices, is that you either have to use IKV2 or you must use their plugin provider. And by the way, not every VPN provider has a plugin, one. Two, not every VPN provider supports their plugin. For example, I think somebody pointed out to me that the Fortinet plugin was like 5 or 6 years old. Like maybe they built one once, put it in the store, and then they've just kind of left it for dead. So it may be out of support by the provider. So anyway, proceed cautious if you go down that route, and make sure if you're sticking with any of the big ones, Cisco, Palo Alto, Checkpoint, probably all support it well. Some of the smaller providers may not. Just a heads up on that. That being said, so let's talk. I threw out a couple of of terms there like IPv2 and SSTP. Let's dig into that just a little bit more. So when we're talking about VPN protocols, in the Microsoft space with Windows, there's two predominant protocols that we would deal with. They support more are supported, and I'll talk about why we might not want to use those. But there's two predominant ones that we want to really focus on, and the first is IPv2 or Internet Key Exchange V2. IPv2 is an open standard, so this is a documented standard, if you will, RFCs and so forth. Fundamentally, IPv2 is really IPsec. IPv2 is essentially all of the mechanics around building, maintaining, establishing, and managing IP security associations or SAs. That's fundamentally what it is. So when we talk about IPv2, IPv2 is really at its core IPsec. IPv2 uses ports UDP ports 500 and 4500. The initial connection is established on UDP port 500. Part of the initial handshake is NAT detection. So part of the handshake is the peers exchanging their IP addresses. And if they don't match, then there must be a NAT, a network address translation device in line, which I'm going to say is probably 99.999% of the time. There's almost always NAT on the internet, right? So especially with IPv4, 100%. And so if a NAT is detected, it switches to UDP encapsulation for IPsec, which operates over UDP port 4500. So that's NAT traversal for IPsec. So the protocol itself is somewhat complex and does pose some operational limitations, specifically around firewalls. So not all firewalls allow UDP ports 500 and 4500 outbound. Even though IPv2 supports NAT, it doesn't play well with a lot of NATs, especially consumer grade home networking equipment. So I've seen lots of problems with that simply because somebody has some cheap a Timu router at home or something, and it just doesn't work well with NAT in general. So operational limitations are always a challenge for IPv2. There are some known performance issues. I really need to go back and research this and see if they're still in place. But when Windows 11 first was introduced, there was a whole bunch of problems in Windows 10. And when Windows 11 came out, there was a couple of them were fixed and some were not. And I don't know if Microsoft ever finished them, but bottom line was there were some times when you would use IPv2 and performance would be absolutely horrific. And it was related to some known issues and limitations with third-party drivers and how Windows was handling some of that. And so there were I've actually fixed a couple of customers by rolling back drivers. Like new drivers were problematic. We had to go back to old ones to get performance. I don't know if all of those have been addressed, but there are challenges with that. Be mindful of it. When you're doing performance testing, you might want to do some throughput testing and validation just to make sure that everything's happy there. That being said, IPv2 is a great protocol from a security perspective. There are a lot of capabilities in IPv2 that allow you to improve security a great bit. By default, it's not fantastic, though. I think we'll talk about that in just a minute. Let's talk a little bit about SSTP, though. So SSTP, or Secure Socket Tunneling Protocol, is a Microsoft proprietary transport. So this will only work if you are connecting to Microsoft services, that being Windows Server routing and remote access, or Azure VPN gateway, not virtual WAN. Virtual WAN does not include SSTP support. Azure VPN gateway does, but only in a limited fashion. It only supports, I think, 128 concurrent SSTP connections or 256 in active gateway mode. Regardless of SKU. So like typically when you go to higher SKUs, you get more concurrent connections, and that's the case with IPv2, but not with SSTP. So I really like this protocol because it uses TLS. It is Microsoft proprietary, but it does use TLS. So TLS being HTTPS, essentially, SSL. And all the traffic flows over TCP port 443. So all of our VPN traffic is basically encapsulated in HTTP and secured with TLS or SSL. And the beauty about that is it's very firewall friendly. It works everywhere. You can get a VPN connection out as long as you have access to the internet. If you have an internet connection, you would 100% have outbound HTTP port 443. If you don't, then you don't have internet access. So this is what makes this protocol really compelling is it just works everywhere. I have found that it offers the best performance. I've actually done some throughput testing, and I'm surprised that a protocol that is based on TCP outperforms a protocol based on UDP. There may be some other factors at play there, but don't think that just because it's using TCP that it's going to be inherently much slower than UDP, than IPv2 running over UDP. You would think that, but that's not been the case in my real world observations. So um, one of the questions I get now, because we're talking about IPv2 SSTP, um, one of the questions I get is, well, which protocol should I choose? Which one should I use then, IPv2 or SSTP? And the answer is, it depends. So whether or not you should use IPv2 may be decided for you. For example, you must use IPv2 if you are using non-Microsoft VPN devices. So if you want to terminate your always-on VPN client connections against your Palo Alto or your Checkpoint or your SonicWall or what have you, then IPv2 is the protocol you have to use. Those platforms do not support SSTP. If you are using the device tunnel, the device tunnel requires IPv2. Even if you are terminating against a Microsoft platform, the device tunnel itself is limited to using IPv2. If you are looking for the highest level of security, IPv2 is your choice. So what I say is basically, hey, so first of all, SSTP still offers very good security. I would say that IPv2 has the capability of being just a little bit stronger for a variety of reasons. However, by default, that's not the case. And in fact, the default settings for IPv2 are really, really poor. So if you've implemented an IPv2 VPN using Microsoft technologies and not made any adjustments to your IPsec security parameters, it is terribly, terribly insecure. SSTP would be leaps and bounds more secure. But IPv2 has the switches and the dials to be able to ratchet uh, the protection or the security up to something that's probably higher than SSTP. So I typically recommend using IPv2 um, if the highest levels of security are required, meaning if you have nation state adversaries, so if you're a military or defense contractor, if you are maybe in finance, maybe medical research, maybe there's some areas where people are really interested in the things that you have, banking, international finance, like I said, those types of things, and you want to ensure the highest level of security, IPv2 is your choice. You do have to accept some of the operational limitations of IPv2, like it doesn't work well behind some equipment, doesn't work at all behind restrictive networks, and you have to kind of accept those things if you want the highest level of security. SSTP is great in most scenarios. You can use it when you're using RAS or the Azure VPN Gateway, and that's it. So if you're using something else, you got to use IPv2. The user tunnel supports SSTP. The device tunnel does not. It offers very good security. There is some additional tweaks that you have to do. In server 2019 and earlier. In server 2022 and server 2025, Windows Server supports TLS 1.3, and TLS 1.3 is secure by default. You can't really mess that up. But there's a few minor adjustments that you might want to make, like security hardening, like disabling TLS 1.0 and 1.1 and things like that. Maybe if you know all of your clients support TLS 1.3, you can even get rid of TLS 1.2. But TLS 1.3 is very, very secure. So in that regard, SSTP is a great choice for the user tunnel. So let's talk a little bit about always-on VPN and Intune. And before we get on, just making sure that we don't have any questions in the chat. Looks good there. Any questions pop up, don't hesitate to jump in there. We'll make it interactive. Always on VPN and Intune. So as I mentioned before, Intune is really the platform of choice to manage always on VPN client configuration settings. And in fact, it's one of the first workloads that I'm personally aware of that required MDM. When always on VPN first arrived on the scene a number of years ago, it's about 6, 7, 8 years ago now. Um, it was kind of frustrating because no one had Intune deployed, and yet it required Intune. And so there were workarounds where you would use PowerShell with the WMI to CSP bridge and things like that. It was kind of clunky. When Intune was first when Always on VPN was first introduced in Intune, well, excuse me, before native always on VPN was supported in Intune, the only way you could do management for always on VPN settings was using custom XML. And so that was a real challenge because you had to write this XML file yourself. It's well documented, but it's not super clear as to how things get set up, what's required, what's not required on the Microsoft site. Is awful. So if you're using that, I think they published an example script, and that example script is absolutely atrocious. So if you're using that, probably not a good idea. Anyway, there was a lot of challenges and issues at the outset. Fortunately, Microsoft did adopt always on VPN into Intune mostly. We'll talk about its limitations. It usually works quite well. There's a couple of bugs even today. We'll get to those. But anyway, the story is much easier today. So if you're just getting into this or just recently, you missed all the pain of the early days. So count yourself as lucky. So we deploy our always-on VPN client configuration settings using device configuration policy templates, much like you've probably done all this week with Intune, right? Um, and there's a couple of different ways to do it. So first of all, you can do this with the VPN template because it does now support always on VPN, or you can use the custom option where you build your own XML and then upload that. There are scenarios in which you might want to use the VPN profile. There are scenarios in which you might want to use the custom profile, and we'll talk about that in a second. The VPN template, the native VPN template in Windows has some limitations. And there are some rather critical ones. So, for example, you cannot disable the class-based default route in the Intune UI. You can't deploy profiles in the all users context. So there are some scenarios in which you may want to deploy the VPN profile in the device context so it's available to all users. That's not supported using the VPN profile. You can do that with custom XML, but you can't do it with the VPN template. And then finally, you can't configure IPv6 routes. So if you're using IPv6 internally, then there's no way to configure routes for that in the UI. And then you can't configure routing metrics or interface metrics, which are really crucial to um, kind of fine tuning the always on VPN client configuration. There are some scenarios in which you might have overlapping routes. So having different route metrics helps Windows decide which interface to use so you can prioritize that traffic flow. Same thing with interface metrics. Windows by default sends DNS queries out all network interfaces, and it will, when it receives responses to those DNS queries on multiple interfaces, it has to prioritize the response. And so it does that using the interface metric. And there are some known problems with if the interface metrics aren't dialed in correctly, that you could get the wrong response back. That comes into play oftentimes when you're using split DNS. So you have split DNS being same namespace internally and externally. And so you could get a private address back when you wanted a public or vice versa. And that could be a real problem. So I just want to go through a demonstration, just kind of showing you a little bit about some of the things that we talked about and also cover some best practices for deployment. So as I'd mentioned, we're going to use a device configuration profile. So I'll go here to, no, I just want to go to configuration. And I'm going to create a new policy. And here, when I create a new policy, I am going to use Windows 10 and later and templates. And then here I have some different templates to choose from. If I go to search and just type in VPN, I get a VPN template. If you select this option, uh, this is kind of you get the standard UI, right? So I'm just going to put in here test. And this is a user connection, and then I have to select my connection type before, and you'll see that it asks me for the connection type before it builds out any other information. So this is critical. So here, what am I going to do? Is this going to be an F5 Citrix connection? These are the native types. One of the things that you will notice here, this is a limitation of the Intune UI, is we have native type, automatic IKV2, L2TP, and PPTP. So quick word about L2TP and PPTP. These are legacy VPN transport protocols. Both have been deprecated. PPTP has been it was really popular like in the 90s. It was super easy to set up, but it's broken. It's fundamentally broken, terribly insecure, can be cracked in minutes with tools that are online. So no one should be using PPTP. I would love it if Microsoft just took this out of here. They did deprecate PPTP in Windows Server, so you won't be able to, it's not enabled by default anymore in Server 2025, and I think going forward they'll probably remove that transport from Windows altogether. So that'll be a good thing because it's terribly insecure. L2TP is an older, it's basically an older version of IKV2. IKV2 replaced L2TP. So you might need L2TP if you have really, really old out of support clients like Windows Vista or XP. I don't know. Bottom line is SSTP and IPv2 are the two protocols of choice. You should pretty much ignore these. But what you don't see in this list is SSTP. It's terribly frustrating because that is an option. It's just not exposed in this UI. So the way we get SSTP here is we select automatic native type. And the way it works is that when it's in automatic mode, it tries SSTP first. And if it doesn't work, it will try IKV2. Um, if you have access to the internet, SSTP is going to work. So basically, automatic means SSTP. When you do this in XML, you can actually tell it to use SSTP. So anyway, um, very good. So, and at this point, it's kind of like a wizard for much of the things that you've probably been doing all week. Wi-Fi is the same, everything else, firewalls, what have you. We're just going to go walk down through these drop-down lists and cover some of them. So we'll give this a name, VPN. And from here, then I'm going to specify my servers. These are my VPN server endpoints. So I'm going to provide an IP, not an IP address, a host name. By the way, you'll see that the example does indicate an IP address right there. Please don't use that. You would never use an IP address here. You must always use an FQDN. And the reason for that is because if we use an IP address, the IP address is not likely to be on the subject, listed on the subject field on your certificate on the back end. And so you'll get a subject name mismatch. And so in that regard, we want to always use an FQDN here. Now, what's interesting here is that you'll see this option for default server, true or false. I can leave this blank, and I'm going to describe what the limitations are here in just a second, but you can ignore this or you can set it to true. It really doesn't matter. Basically, Always On VPN ignores this setting. It really doesn't care. By the way, there's a description here. Most of the time, descriptions are optional. Here, for whatever reason, the description is mandatory, so you do have to put it in description here. Now, I could just move on from here, but you might be asking yourself, because I certainly have, is there are additional servers here. And by the way, it's asking you which one is the default. So I could put another one here, right? So VPN2.Hicks.net. Intuitively, you would think this is a good idea, meaning if it connects, since this is the default server, if it doesn't connect or that's not available, it will just fail over and dial or connect to VPN2, right? Unfortunately, it doesn't work that way. Always On VPN only ever uses the first one in this list automatically. You can put additional servers in here. However, they do not provide any sort of automatic failover. If the connection fails, they will actually appear in the drop-down list. So your users could go into the VPN settings, select a different server, and then connect to that. But that's a manual process. It doesn't work automatically. Typically, what we will do, however, is just set up a single host name, FQDN. Typically, it resides, it maps to a public IP address, which is netted to the private IP address of the server. If you have multiple servers, they might be on premises. They might be behind an on premises load balancer. You can certainly use things like Azure Traffic Manager to handle uh, traffic connection request routing, especially if you're doing something like geographic load balancing. You have servers in multiple data centers around the world. You may want to intelligently steer traffic to those data centers, right? No sense for your users in London to be connecting to Los Angeles VPN servers, and vice versa, right? So you can say, hey, listen, you can use something like Azure Traffic Manager. And by the way, AWS Route 53, Cloudflare, there's tons of global server load balancing solutions out there like Traffic Manager, but Traffic Manager is super easy to set up and configure. So, but you can use those solutions to say, hey, listen, I'm in this part of the world. Give me the entry point that is nearest me. And if it's not available, then route me to the next nearest one. And those are defined in Azure Traffic Manager profile settings. And I used Azure Traffic Manager quite extensively when I'm deploying always on VPN in those scenarios. But in that case, all of the traffic routing is basically behind this name. This name is hosted in Azure, and then Azure Traffic Manager decides which IP address to give me that client back to connect to that particular resource. And of course, the beauty here is that Azure Traffic Manager monitors that as well. All right. So the next setting to consider is this register IP address with internal DNS. You may want or need to have your remote connected VPN clients reachable from the internal network by their name. They're always reachable by IP address, by the way, but you may want to be able to reach them by name for a variety of reasons, right? Ease of management. So if you select this option, that will, when this client connects, it will automatically register its IP address for the VPN connection in your internal DNS. This sounds like a great solution, but it has some serious drawbacks. First, every time the client connects to the VPN, it gets a new IP address. What that means is that each time it connects, it's going to re-register. We're all familiar with DNS propagation delays and caching. And so if you have a connection that's dropped, like for example, a customer's connected and their connection drops intermittently, or maybe they're traveling and they're on Wi-Fi and they connect to the 5G and that's every time they connect and disconnect, they're going to get a new IP address and re-register in DNS. And so that can be problematic. Also, the fact that a lot of organizations are big and they have DNS all over the place. DNS propagation delays are a real thing. And since this is happening kind of dynamically, your mileage may vary with this. I have a lot of customers that have tried this and it gets very frustrating at times because DNS never seems to return the right IP address. So that being said, if you need that, you can enable it. It just may not be perfect in operation. Of course, this is the button here to basically make it an always on. If I just wanted to create an ad hoc user initiated VPN, I would just leave this off. And then they would just be there. It'd be a VPN profile on the endpoint. The user would have to click on it to connect. But here we're talking about always on VPN. So in this case, I'm going to set the option to always on. Remember credentials at each login. This is a setting I want to caution you for. If you are using usernames and passwords for always on VPN, this is a good setting. However, I don't recommend using usernames and passwords for always on VPN. For always on VPN, so usernames and passwords, the problem with usernames and passwords are that those credentials are easily stolen, easily compromised, commonly shared. They don't work well for us, especially for critical workloads like secure remote access. This remote access gateway is open to the whole world. And if somebody phishes one of your users and gets their username and password, the first thing they're going to try is looking for VPN gateways and see if they have remote access, right? That's just a no-brainer. So we don't want to use usernames and passwords because again, they're highly fallible. We always want to use certificates for authentication, both user and devices. And that way we can tie those certificates to the machine, basically make hardware backed certificates, TPM backed certificates. And that way they can't be compromised. Once they're issued to the endpoint, they can't leave. Even if you have administrative access, you can't extract the certificate. So it's a very, very robust, strong authentication mechanism, one that is well suited to using for VPN. In that case, you don't need to check remember credentials at log on because there's no credentials to remember. The user doesn't have to type anything in. It just uses the certificate that's been issued to them. So if you're using certificates, which I highly recommend, you can just leave this as not configured. And in fact, probably a couple of years ago, there was a bug in this, and where if you had set remember credentials to enabled and your certificate renewed, then you wouldn't be able to connect. It would cause problems. So definitely don't recommend setting this. Definitely recommend using certificates. Next thing it's going to ask you for is your EAP XML. So when you're using always on VPN, especially with the Intune native profile, they're expecting you to use some form of EAP, which is extensible authentication protocol. EAP isn't necessarily a protocol itself, it's more of a framework, but bottom line is it defines how we authenticate to the VPN. The challenge with this here is, of course, it's not saying what settings do you want to use. It just says, give me your XML. And so a lot of people say, well, where do I get this XML? Well, here's the story. You must first create a manual VPN connection on your test client. So I'm just going to show you how I do this here. Let's see. So I am opening up, this is a tool called rasphone.exe. If you run this on your client and you have VPN connections, you'll see them in this list. So I'm going to go to my always on VPN connection, choose properties. And here's the property. So basically what you would have to do is go and build all this yourself. You would have to select this, select that, choose properties. You'd have to fill out all this information. By the way, if you look at the settings here, I'm choosing to verify the server's, this is the NPS server, the Radius server, verify the server's identity, and then I supply the list of trusted Radius servers on the back end. So these are security best practices you can do without, but it's not a great idea. We select our root CAs. In this case, I think it's down here. There it is. Yep. So I've already selected my root CA for my test lab. There's a bunch of other settings here. And then this is the authentication method. If I choose configure, you can see there it exposes some more settings. I want to use a smart card, or excuse me, I want to use a certificate. This is the information here. If I click advanced, there's even more information in here that I can use to further enhance the security of the solution. Bottom line is you have to do all of this at least once manually. I suggest testing that and making sure that it works. And then once you're confident that it's working, you can literally go and extract that information. So let me do this, bring this PowerShell window over here. Is there anything in here? Oh God, there's all kinds of stuff in here. That's not good. We'll just do it in the root of C. So basically what you would do is, by the way, I have a tool for this. You can do it without my tool. It's just a lot easier with my tool. Basically, what we're going to do is we're going to extract the EAP portion of this policy. So let me take a look at this again. So we'll go to rasphone, go to properties. So basically, keeps going on the wrong screen here, security. So everything in here, so I have selected EAP and I've selected particularly protected EAP, which is a security best practice. So everything in this properties here and here all are basically the EAP configuration that I can extract using PowerShell. And again, you can do this without my tool. There's a couple of commands that you would run, but it's even easier with my tool. So you can get my tool at github.com/Richard Hicks. And if you go into the AOVPN folder, there is uh, there's a tool called get-eap configuration. It's a PowerShell script. And so what I'm going to do is I'm just going to run get VPN connection, and I want to see which profiles I have listed here. So I only have one, so that's great. So that's my always on VPN profile. All right, so I'm just going to do an up arrow, and I'm going to do name and then always on VPN, and that returns the correct uh, profile. So what I'm going to do now is I'm just going to pipe that to get EAP configuration, which is my tool. And when I hit enter, you'll actually see that it saves it. So I'm gonna run a notepad here real quick and EAP config. And so basically, I put it way over here. There we go. So everything that was in that EAP configuration, all those menus, is all contained in here. You would never, ever, ever attempt to create this yourself, right? This would be suicide. You never did it right. So best way to do it is just do it manually, make a connection, make sure it works, and then extract it in this way. So then you simply take this XML and you paste it into this window. So that's what they're looking for here. I think the tooltip actually gives you a link to somewhere about how to do that, but my PowerShell module just makes it much, much easier. Also, my PowerShell module formats it nicely and readable for you as well. So that's what we're talking about. Very good. That being said, let's go to app and traffic rules. And the app and traffic rules, you can safely ignore this whole section. So first of all, Microsoft is deprecating WIP, Windows Information Protection. They're getting rid of that. So there's no need to invest in this. By the way, I've been doing always on VPN for almost a decade now. Have not had one customer use this. So nobody uses WIP, which is probably why Microsoft is deprecating it, right? Nobody's using it. So I'm just going to ignore this whole section. You don't have to do anything in there. We will go to conditional access. If you are going to, as I mentioned before, you can configure Always On VPN to support conditional access, and you can create conditional access policies to control VPN access. It's a fantastic tool. If you want to do that, it's not exactly trivial. And in fact, I have a blog post and YouTube video on this. So I would suggest you can go to YouTube. If you go to richardhicks.com/YouTube, that'll bounce you into my channel, and you'll find it there. I don't have a ton of videos. It's easy to find. You can search for it on my website as well. I have a step-by-step guide there. But bottom line is when you're doing that, there's a couple of these that you're going to have to select. So you'd have to enable it. You would have to tell it which certificate we want to use for SSO and provide some information about that certificate. I'm going to leave those disabled for now. And where's that? It's disabled those. And we're just going to ignore that for now. But know that this is more of an advanced setting. And if you need that information, like I said, have a blog post, have a video, you should be able to get it set up pretty easily. So that's conditional access. Our DNS settings are crucial because we do need to be able to resolve names over the VPN connection. So that's obviously very critical. So we're going to add our DNS suffixes. These are basically your on-premises DNS suffixes. So in my lab, it's very easy. It's lab.richardhicks.net. And by the way, if you have in multiple internal DNS suffixes, you can certainly add them here. So that's not a problem. You will see there's an option for name resolution policy table or NRPT rules. NRPT is optional. If you're familiar with direct access, it was required in direct access. With Always On VPN, it's optional, and I suggest you avoid it as much as possible. I can count on one hand the number of times I've had to use NRPT to solve some weird problem, but most of the time there are other options to using it. The NRPT, if you're not familiar with it, the NRPT provides policy-based name resolution request routing for DNS queries on the Windows client. In other words, instead of just sending the DNS query to whatever the DNS server is on the network adapter, it will send it to a specific administrator-defined DNS server. So I can basically override local DNS settings. My local DNS settings might say, hey, use Google DNS, but I'm saying No, use my on-premises DNS servers that are Active Directory integrated, right? So in that case, I can tailor my DNS responses to that way. The problem with the NRPT is that it's difficult to support. Not all applications support the NRPT, so not all applications are NRPT aware. So you get odd behavior at times. Some applications use it, some applications ignore it. It makes troubleshooting more difficult. Other things might be using the NRPT, which will conflict because you can only have one table. Anyway, I avoid it as much as possible because it ends up causing more problems than it solves. So I'm going to leave this alone. I would suggest wholeheartely that you do the same. Proxy settings. I want to talk a little bit about proxy settings. So proxy servers were a big deal in the 90s, right? We use proxy servers all the time. As a matter of fact, in IT, it was one of the first server workloads I think I ever worked with, Microsoft Proxy Server 2.0. Great solution for caching the internet back in the day because you didn't have much WAN connectivity and internet was slow, and they were great tools. They're not super common today. But we certainly have a lot of cloud proxies, maybe a lot of organizations still using them for security filtering, things like that. Um, you'll see a bunch of settings for proxy servers here. So I can use an auto configuration script, so an auto configuration file. I can specify a specific or explicit proxy and the port, and I can specify a whether or not I want to bypass local addresses when using the proxy server. What you do not see anywhere in this is that the proxy server only works when you have forced tunneling enabled, which is we're going to get to that in a second. If you're using split tunneling, you can put whatever you want here. It's completely ignored. So also, I have found that not all applications, even when you have forced tunneling enabled, will pick up these settings. So it's kind of clunky. So we try to avoid proxies as much as possible, but if you do have to use them, we do have some proxy integration capabilities here. Split tunneling. We need to tell. So first of all, when the VPN client connects, it's going to get an IP address that's routable on the internal network that it's connected to. And what we need to do is tell it what traffic flows over this VPN tunnel. Do we want everything, which is called forced tunneling, which means even internet traffic goes over the VPN? Um, the forced tunneling is I say it's been deprecated. It hasn't been formally, of course. It is an antiquated solution that was popular in the 90s and early 2000s, where organizations would want the VPN, all their traffic going over the tunnel and egressing their on-premises security gateways so they could do traffic inspection, content filtering, logging, and all that stuff. All great stuff. But today, um, there are more elegant solutions to do that rather than a heavy-handed forced tunnel. We prefer doing split tunneling and then using more modern solutions like, well, today it's Global Secure Access has internet access, right? So we'll talk about that at the end. But Zscaler, Netscope, there's a whole bunch of them out there. Cisco has one, I forget what it's called. But anyway, they're basically cloud secure web gateways. And so what you do is you enable split tunneling, but you still have those controls in place. We just use a more modern mechanism to do it. So typically we would enable split tunneling, and then we have to define, of course, if we're not going to route everything, what do you want to route? So let's say I'm going to route my whole 172.16.0.0 network, and then my prefix size is /16. What that means is that anything bound for 172.16 would get routed over the tunnel. Anything else would go outside of the tunnel. And I could have multiple prefixes here. I suggest summarizing as much as possible. So don't, like, let's say, don't do 172.16 1.0 and 2.0 and 3.0 and 4.0 and just do, hey, let's just do the whole block, or try to at least summarize those blocks just so that your routing tables are a little bit more concise. But bottom line is we have to add those there. And then finally, trusted network detection. Trusted network detection is helpful because we may not want the VPN to connect while we're on premises. In other words, if I'm on the corporate network, why would I want to connect to the VPN, go to the internet, come back in to get to that resource that's probably, sitting in the room next door? right? So there's no point in doing that. So what we have is something called trusted network detection, where always on VPN will determine if it's on a trusted network. And if it is, it won't light the VPN automatically. And it does that by suffix. So it's the same as my domain name. And so that's my DNS suffix. And then I will just add that. So when always on VPN starts, it will look for an active network interface that has this DNS suffix. And if there is one that matches this string, always on VPN knows it's on the internal network, and so it won't start the VPN. If it doesn't find a match, it says, hey, I'm not on any trusted network. I must be on the internet. Let's go ahead and connect. And so that's pretty much it. At that point, this is standard stuff. You can do your group assignments, you can do your excluded groups, you can do applicability rules and scope tags and do all that good stuff. And everyone here probably has to do that, has already done that this week. So I won't beat a dead horse there. So that being said, I want to take a short break, just 10 minutes, and then we will reconnect and go on and talk a little bit about we'll wrap up on this. We'll take any other questions, and we'll talk a little bit about Intune. 10 minutes good, Johan? Good for you?
Absolutely, sir. It's
Uh,
perfect. Thank you.
all right, let's drop for 10 minutes. I want to put the timer up right now, and we will come back in just a few minutes.
All right. See you soon.
Thanks, everybody. All right, everybody. Hopefully everybody's back. Stretch legs. Get an afternoon pick me up.
Absolutely. Got coffee and chips because chips goes well with PKI and always on VPN.
Absolutely. Or for our friends who might be joining from Europe, feel free to enjoy an adult beverage. It's past 5, right?
Yes, it is. Heck, it's close to midnight over in
Midnight. Yeah,
Europe.
that's for
Yeah.
sure. Yeah, they're probably on their second or third by now. Good deal. Fantastic. So let's pick up where we started. I've got another hour-ish. Hopefully finish up on time, but might run a little bit late. We'll see how it goes. Because we have a lot of fun stuff to talk about. I do want to talk about deploying certificates with Intune because I had mentioned before, always on VPN, if you're implementing it according to security best practices, you're going to be using certificates to do this. And if you're using Intune to manage the endpoint, then you certainly probably need to get certificates out to those endpoints for authentication, user and device authentication. So let's talk a little bit about that. Again, we're just gonna scratch the surface here. I would encourage you to visit to register for our masterclass because we'll spend 3 days talking about certificates in Intune. That's how deep that class is. So anyway, if you're interested in that, we're going to scratch the surface here, but I'll give you a few little tips and tricks just to make sure you guys are in good shape. First of all, we deploy certificates using Intune, using the certificate connector for Intune. And with the certificate connector, and by the way, this is just a piece of software that gets installed on an on-premises server, and it talks out to the Intune service, very much like the offline domain join connector or the Entra sync connector. Same principle, right? It gets installed on the server, connects outbound, and it basically brokers the communication from your internet endpoints to your on-premises enterprise PKI. And when we install the certificate connector, there's a couple of different ways to configure it depending on how we are enrolling for certificates on our endpoints. And there's two ways to do this. One is with something called PKCS, which stands for Public Key Cryptography Standard. Specifically, this would be number 12. PKCS, you may be familiar with as PFX. So PFX, you've probably used a PFX file if you've ever done any work with certificates in Windows. PFX is basically an archive file format, and it contains the certificates, maybe multiple certificates, and of course the private key. It's password protected and things like that. So that's what we're talking about here. The advantage to using PKCS certificates is that they're very easy to deploy, much, much simpler than doing certificates with the other alternative, which is called SCEP. The advantage to using PKCS is that you install the connector and that's it. There's no inbound access at all. You don't have to publish anything. You don't have to have load balancers. You don't have to use application proxies. You just install the connector and you can do this. It's very quick and simple. It's a good way to keep your sanity. You can use PKCS for everything. I've not run into a workload that couldn't use PKCS myself. So it's really the best way to go. We recommend using that. The other alternative is something called SCEP, which is the Simple Certificate Enrollment Protocol, which is a protocol or a standard that's been around for many, many years. It was originally developed by Microsoft and Cisco, I think, in the early mid 90s. And the idea behind SCEP was they needed a way to enroll certificates on non-Windows devices, particularly routers and switches. And so they came up with this solution to deploy it. And so SCEP, with when you deploy SCEP, it's much more complex. You do have to, when you install a certificate connector, it's not just the connector. You also have to install the NDES role. NDES is Microsoft is basically Network Device Enrollment Service, and Microsoft NDES is the Microsoft implementation of SCEP. That's their implementation of SCEP. So you have to install NDES first, and then install the certificate connector. Installing and configuring the NDES role is not trivial. And in fact, in our masterclass, we spend an entire day, 8 hours covering NDES configuration. It is terribly complex. There may be some reasons you would need or want to use it, but it is not for the faint of heart. It is very, very easy to get wrong. And if you get it wrong, you can really expose your organization to near instant domain compromise by not doing the right things. Also, NDES requires that you publish this to the internet. So it requires inbound connectivity. What that means is getting the networking team involved. And if you're exposing a web service, you probably got to get security involved and they got to do their pen testing, and it gets out of hand in a hurry. PKCS is the way to go, trust me. But there may be some corner cases in which you do have to use SCEP. But just understand that if you got to use SCEP, it's going to be much more difficult. That being said, we have another alternative, and that is Cloud PKI for Intune. Microsoft introduced this a couple of years ago, and it's basically a cloud service. And the nice thing about this is it is just certificates as a service, much like mail as a service or SharePoint as a service. We really don't care about the backend infrastructure anymore. We wash our hands of it. We just say, give me the certificates, and it's awesome. No infrastructure is required to do this. It is secure by default. The challenges or the limitations of Cloud PKI is that it only works for Intune managed endpoints. So it is not a complete replacement for on-premises ADCS. Like, for example, I can't issue server certificates for it. So I can't do issue certificates to my domain controllers or my NPS servers or Radius servers. There's a lot of things you can't do with Cloud PKI for Intune. We cover Cloud PKI for Intune in the masterclass as well. We cover it really, really thoroughly, so you'll get a good handle on what it can be used for and what it doesn't work well for there. But the advantage to using Cloud PKI is that it does have cloud-hosted SCEP. So yes, SCEP or NDES is really, really hard to set up, but with Cloud PKI for Intune, it's all running for you. It's just a service. They give you URL and you just use it and it works great. So you wash your hands of all of that. Also, one of the things that I like about, or one of the deployment models that I like about Cloud PKI for Intune is it does give you the ability using something called BYOCA or bring your own CA. It allows you to extend your existing on-premises Active Directory certificate services deployment to the cloud. So basically what I can do is I can create an issuing CA or subordinate CA in the cloud, and I can subordinate that to my on-premises root CA. And so basically I can get the best of both worlds. I have my on-premises Active Directory certificate services set up to do server certificates, client authentication, device authentication for domain join properties, to servers, workstations, what have you. And then I also have this CA in the cloud that is issuing certificates to cloud-based devices. And so in that scenario, again, I get the best of both worlds. It's a really, really good one. So we cover BYOCA extensively in our masterclass. If you want to learn more about it there, hope to see you in that class. The cloud service, of course, is not free. Microsoft has got to make some money. It requires the Intune suite, so you get Cloud PKI for Intune by using the Intune suite. It is available via add-on licensing. I forget what all is in the Intune suite. You probably covered that this week. I don't know. There's a bunch of stuff in there, but Cloud PKI is one of them. You can also buy it kind of standalone, add-on licensing. I think it's $2 per user per device. I forget. Anyway, but it does have you do have to license that, so just be mindful of that. I do want to talk about some certificate profile best practices. So, regardless of how or where you're getting your certificates, whether it's cloud PKI or on premises via the connector, we're going to use a device configuration profile in Intune. And I want to go through some of those security best practices when you're creating that. The first one that I like to really, really drive home is use TPM. And I'm going to demonstrate. When we get to the demonstration, I'll show you that. We definitely want to use TPM as much as possible. And in fact, my recommendation is to use the TPM, otherwise fail. And the reason for that is we don't want certificates with private keys that are exposed to us and not knowing about it. So here's the deal. A certificate and private key, really the private key is the most critical point of the certificate, right? The private key must remain private for that certificate to be really useful. And if the certificate's private key is exposed, then anybody else could use that certificate as well. And by the way, they would be able to use that certificate without knowing the password, which is really critical. So we want to make sure we're protecting the private key. If we don't protect the private key with TPM, then it's just a file on the disk that's protected by an ACL. And there are tools that you can use that are readily available that you can extract the private key, even if it is not marked as exportable. Marking the certificate as exportable is nothing more than a suggestion to Windows to enforce this ACL, but you can get around that in an instant. So if you're not protecting certificates with private keys with TPM, they are easily compromised by a determined attacker. If you issue certificates and ensure that the private key is stored in TPM, no one can extract them, not even someone with local physical administrator access to the box. So those private keys are very well protected. So we absolutely want to ensure that we're using TPM, and I'll show you that in just a second. Also, when you install the certificate connector for Intune, please understand that that certificate connector server now has very, very privileged access rights to your CA, your issuing CA, specifically the template that you granted access to. Fundamentally, when you install the certificate connector for Intune, the certificate connector server becomes a control plane asset, or in the old tiered model, it's a tier 0 asset, which means it is functionally similar to a domain controller or an issuing CA. It is very, very highly privileged, should be protected and monitored in your environment as much as you can, just like you would a CA, an issuing CA, or a domain controller. The certificate templates, make sure that you are using client authentication only. There are some scenarios where you might want to use custom application policies, and we'll talk a little bit about that shortly. But I want to give you just a quick demo here and show you what we were talking about here. So let me bail out on this. And when we created that policy, I'm going to go to an existing policy that I've already got. So lab user authentication, PKCS. Let's do this one. So this is one that's already existing, but I'm going to go look at the settings and just walk you through how I have this set up. Now, when you set this up, you'll see that I've set the renewal threshold at 20%. That means that 20% of its available lifetime is left. So if it's good for a year, when you get down to about 5-6 weeks, it's time to renew the certificate. So it will attempt to renew the certificate prior to its expiration. And Kevin, I'm going to get to your question in just a second here. So sit tight. The validity period, by default, the validity period is 1 year, I think, when you set this up. The industry as a whole is trending towards shorter certificate life cycles. And in fact, you may be familiar with the fact that public TLS certificates from public CAs like DigiCert and so forth will be reduced to 47-day maximum lifetime coming up, I think, in 2029. But they are going to be shortening the lifetime before then. The first milestone is March 2026. So just next year, they're going to shorten that certificate. The maximum today is 398 days, so roughly 1 year. They're shortening it to 200 days. So that's going to be about 6 months. The following year, they're going to shorten it to 90 days or 100 days, technically, is what they're doing. So they're shortening this, and they're going to eventually land in 2029 on 47 days as the longest public certificate you can get. Now, with a private CA, you can do whatever you want. I can make the certificate be 100 years if I feel like it. Not a good idea, but you can. But there are reasons to consider shorter lived certificates than 1 year. First of all, if we're enrolling for certificates and renewing them automatically, we really don't care. We don't have to do anything. So if I use shorter lived certificates, if there's a problem in the future that I need to make adjustments on, let's say RSA is now not good and you got to switch to some other, you got to switch to EC. If all of my certificates are out here valid for years, those are exposed for a long time. If I shorten up my certificates to say 1 month or 3 months or even 6 months or something like that, my exposure window gets reduced. It also means that if other changes come up that I need to make, they will just naturally roll over much more quickly. Where we saw this come into play was with the security updates this year in February and September. So in May of 2022, KB 501-4754 was introduced, and I always laugh at that because anytime you can remember a KB article by its number, from memory, it's an important one. I've been talking about this for years. They introduced strong certificate mapping to kind of mitigate some of the risk to some certificates that they were seeing attackers kind of abuse certificates in the wild. And so Microsoft put some additional controls in place to ensure that those certificates were more robust. And basically what that meant was strong mapping, meaning the domain controller now will only accept a certificate for authentication if it is strongly mapped. So in other words, we have to either embed the SID or in a variety of different ways, or map the certificate to a specific certificate there's a variety of different ways to do it. But bottom line is that changed recently. And I had a lot of customers who missed that and said, oh, now I have all these certificates out there that are valid for a year and they're not strongly mapped. Oh, and of course, I had many customers ahead of that deadline who said, "Oh yeah, we'll make the change now, but I'm going to have some certificates that won't renew in time." And so you have to force the issue. But I had many customers that I've been working with that I had convinced to move to shorter certificates. When we made the change, we just said, hey, we don't have any certificates that live longer than 3 months. This change doesn't come up for 6 months. I'm going to make the change now and I don't have to do anything. It'll just take care of itself before that. So basically what it does is using shorter certificate life cycles gives you some more agility. It's not without its downside. I mean, there's some things you have to consider about it, but I think that there are some potential advantages to that. I wrote a blog post about it, and if you go to my website directaccess.richardhicks.com, I do a search there, and you find that article. I talked about the advantages of using shorter certificate life cycles in the enterprise and what those benefits are. You might be interested in that. So here I'm using 1 month because this is my test lab. I don't need a 1 year certificate. Nothing lives longer than probably 20 or 30 days in this lab. If it's 2 or 3 months old, that's really old. Everything turns over. So I don't want a bunch of certificates out there that have long lifetimes. So I talked about the key storage provider, enroll to TPM, otherwise fail. Meaning, if I'm issuing this certificate, I want to ensure that it is stored, the private keys are stored on a TPM without exception. What I don't want it to do is silently fall back to an insecure method, and then I won't know. So there may be scenarios in which you do have to issue a certificate to a device without a TPM. Those should be an exception. That should be a separate policy. I recommend probably a written, some sort of written policy that makes the user or the department manager or the cost center accept the risk of rolling a certificate to a device without a TPM. I would say that those certificates without TPMs should be extremely short-lived, maybe 1 to 2 weeks, maybe even a few days. It depends on what it is. At the end of the day, that is a considerable risk. And so I like to use otherwise fail here. And if this policy doesn't work for you, then you get an exception policy. One, I want to find out if you have a TPM, is it not configured? Is there a problem with it? Why are you using a certificate device without a TPM? Most everything should have TPMs now. So anyway, the certification authority, this is the host name of the CA. So this policy is tied to this CA. If I had 5 issuing CAs, this server is always going to talk to this one, period. So it introduces a bit of a single point of failure. Shouldn't be too critical, but understand you can only point it to one server. It'd be great if this field accepted multiple servers, but it does not, unfortunately. This is the CA name, and this is actually the what's known as the distinguished name of the server, and this is part of the config. You can actually see this. Let me go take you to the lab environment here real quick. Where is my server? Shoot. Too many windows here. If on a this is a lab. This is one of my lab. This is my lab management workstation. So if you want to find out the name, the distinguished name of that server, you just simply run the command certutil.exe without any parameters. It will dump a bunch of information for you. In fact, certutil without any parameters is actually just certutil-dump. But anyway, it dumps out the parameters for all the CAs in your environment. And so what we are looking for here is the certificate authority name. So that was this one, I think is what it was. I forget. That's the name that we want. We don't want to use this name. That's not correct. That's actually the config. We actually just want to use the name. All of these names are the same: authority, short name, sanitized name, but this is the name that we're interested in there. So that's the one we're going to use in this particular policy here. Get back to that window there. So that's what goes here. The template name is important. By the way, the template is not the template name is different than the template display name. Let me demonstrate that for you as well. So if we go to my lab, where's that VM again? Here it is. I have, by the way, I have another PowerShell tool set for Active Directory certificate services. It is called ADCS tools. You can install that from the PowerShell gallery, but I can get, I have a command called get, actually, let's just look at that real quick. Command-module, and it is ADCS tools. This tool set has a bunch of PowerShell functions that I've created that do a variety of different things. If I run the command get AD certificate template, this is the one that I want right here. You can see that it will spit out a bunch of information here for you. And these are all of the templates that are in Active Directory. They are not the ones that are published. They're just all of the templates. However, I do have one here that is get published template, because that's going to be more important for us. So we run that. And the nice thing about this is that it shows the templates that are published and which CA they are published on. I am looking for my PKCS enrollment template. This is the template. And by the way, if I look up here in the output of this one, where is it? PKCS enrollment, you'll see that this is the template name, but this is the template display name. The template display name is typically what you would type in the UI when you created the template. The template name is basically the template display name without any spaces, but not always. It can be different. So anyway, use that tool. I suggest using this tool and copying and pasting, because you do not want to have any typos here. Because if you get this wrong right here, if you get that wrong, if there's a typo in there, if you say, oh, I remember what it's called, and you type it in and it's wrong, then obviously this is not going to work. So we choose our certificate type, user or device, our subject name format. There's a variety of ways in which you can define this. By the way, this is documented. If you go to your favorite search engine and type in PKCS Intune certificate, you will get a document here called Configure and Use PKCS certificates. And if you scroll down, These will be listed here. Where is it? Configure the template. Download, install, trusted profile. Where is it? I think it's down here. Coming up to it. A little farther. Subject name format. There we go. So if you go to the subject name format, this will tell you all of the settings that are supported in that field. For a user certificate type, these are the things that you can use. And then, of course, if you're going to use a device, if I scroll down here, uh, these device certificate types, there are different values that you have available to you in the device certificate. So that's where you would find that information that you would put here. So you can put whatever you want or whatever you need. Uh, and so this is for a user authentication certificate. So I'm using the UPN. And also I have the user principal name. So that's one of the values that was defined for our user right here. So user principal name. So anyway, so that's that. By the way, I do want to jump down. Well, actually, let me finish this up. Um, this gets interesting. The values here, typically you would select client authentication, and we would call this a day. I was screwing around with this one because I was trying to demonstrate that this value is actually ignored. So you can really put whatever you want here, but I usually just select client authentication if it's user authentication. By the way, one critical point here. This is for PKCS. Strong security mapping is handled by the PKCS connector server on premises. We actually make a registry setting change there. If you are doing SCEP, SCEP is a little bit different. Let me jump over and show you that. So if I go to SCEP for here and go to the settings, um, it's a little bit different. So you'll see that it is slightly different. It's asking me for less information, so it's slightly different. One of the things that you must do for SCEP is add this URI attribute with the value on-premises security identifier. This will then embed the principals, user or devices SID onto the certificate and enable it for strong mapping. You do not have to do this on PKCS, but you must do it on SCEP. So be mindful of that. If you don't do this, you can't use the certificate for AD authentication. So if this was a document signing certificate, RDP certificate, something else that wasn't really for authentication, maybe secure email as mine, I really don't need this field. But if I'm going to authenticate against AD, it must have this field. So be mindful of that. Also with SCEP, you are going to define your SCEP URL. This is something that you've either created, or if you're using cloud PKI for Intune, they give it to you and you just paste it in here and you're good to go. So those are kind of some of the best practices around certificates for Intune. Getting back to your question, Kevin, yeah. So we have an on-premises NDES server that does certificate requests for iOS devices through Intune, looking to migrate this to cloud only. Is this doable with Cloud PKI? Absolutely. 100%. Any Cloud PKI for Intune issues certificates for all platforms. So it will work for Windows, obviously, iOS, Android, so whether that's tablet, iPhone, iPad, doesn't matter, Android, absolutely. You can issue certificates using Cloud PKI for Intune and use them for whatever you need. You would just deploy those same profiles, just like we did here, and you just with Cloud PKI for Intune, you can't use PKCS. You can only use SCEP. But Cloud PKI for Intune gives you the SCEP URL, so you just paste it in there and tell it what you want, and you're good to go. So, yep. Awesome. Very good. So moving on, I want to talk a little bit about Intune remediation. I believe you guys have done some work with remediation in the training sessions earlier this week. We use Intune remediation for a couple of things for always on VPN. So first of all, we use Intune remediations to kind of fine tune the VPN configuration because, as I'd mentioned before, the default settings are sometimes less than desirable. Sometimes we use remediation because the Intune UI doesn't support some setting that I absolutely need, like disabling the class-based default route. That's a critical one. When I do split tunneling, I want to define my routes. by default, Windows adds a route that is based on the CIDR or based on the class of the IPv4 address that gets assigned to the endpoint. And it does this automatically. And that can yield unexpected results, let's put it that way. And best practice is to disable it. There is no option in the UI to disable it. So I have to disable it after the fact using a remediation. And so we will do that. I might want to do things like enforcing machine certificate filtering by the EKU. There are some scenarios in which we want to ensure a very specific certificate is used for device tunnel connections. And it's basically for high security in deployments. And there's no option to set that in the UI, of course. Same thing. There's an issue with there's a known issue where some certificates, if they're stored on older model TPMs, sub-specification 1.16 and older, I believe, has problems with modern RSAE PSS ciphers for TPM access. And so what ends up happening is it can't access the private key, and so it can't authenticate. And so it can result in authentication failures for some endpoints. And so you can use a remediation. I've written the scripts, the detection and remediation scripts to do that. And the workaround is basically remove those modern ciphers and kind of fall back to the older ones and to support those older platforms. You might also need to do VPN profile cleanup. So for example, if I'm migrating to always on VPN and I had other VPN profiles there before, or maybe I was deploying always on VPN manually, Active Directory through a PowerShell startup script or something like that, and now I'm going to use Intune, then I can deploy them with Intune, but Intune's not going to go back out and remove any other profiles automatically. I have to write that script to go out and find my old connections and remove them. So I have those as well. I do have lots of examples. As a matter of fact, I'll show you here real quick. If you go to github.com/Richard Hicks, I have an endpoint manager repository, which was named Endpoint Manager right when Microsoft changed the name from Intune or from Microsoft Intune to Endpoint Manager, and then when they changed it back to Intune or whatever it was, the repository was called Endpoint Manager, so I left it. So here it is. I'm not changing the name of it. It's still called I have the old Endpoint Manager name here. Bottom line is in this particular repository, I have lots of detection and remediation scripts for a whole host of things that you might need to adjust or fine tune for always on VPN post deployment. And feel free to use those. That's github.com/RichardHiggs/endpoint manager. All right. Getting close to the end here. We got about 15 minutes. We'll try to wrap this up quickly. I want to talk a little bit about autopilot. Autopilot's fantastic. You guys probably use that this week. It's a great tool. I use it for my stuff. It's fantastic. I work with many customers to deploy autopilot, and I've got a fair amount of experience, maybe not so much with the provisioning side, but with some of the mechanics around getting these users connected post implementation. That being said, what I have learned about autopilot, and I'm going to bet money you've heard this already this week, is native entra join is your friend. It's the recommended way to go. Yes, always, yes, Intune autopilot does support hybrid entra join. You can do that. There are some limitations, especially when you do entra join offline. Specifically, if you plan to support offline hybrid intra-join deployment using autopilot, you must deploy the device tunnel and a device authentication certificate. And that's required because when you do this offline, and there's an option in the profile to disable the domain controller check, right? So you can just basically say, hey, I don't have line of sight to domain controller. I'm going to handle that some other way. Just do your thing, autopilot, join it to the domain. Once you get to an authentication prompt, it's expecting to be able to talk to a domain controller, because remember that user is a domain user and they don't have any cache credentials. They don't have a profile at that point. So you have to talk to a domain controller to support that first logon. And to do that remotely offline, you must have device-based connectivity, because there's, again, can't do it at the user level. So for that, we deploy the always-on VPN device tunnel and a certificate. We have to get both of those out to the device. Works quite well under most conditions. However, it does require Enterprise Edition to do this. So if you are doing autopilot, hybrid join offline, and you are planning to use step up upgrade, meaning I'm going to deploy the endpoint as Windows 10 or 11 professional. And then when the user logs on, they have an E3 or E5 license, so they get Enterprise Edition then. And once that user logs on, Windows recognizes that and says, oh, we'll upgrade you. That doesn't work here. And the reason for that is you have a kind of a chicken and the egg sort of scenario. Maybe it's a catch 22. I don't know. But bottom line is the device tunnel requires Enterprise Edition. And if the device is pro, I can't support that first logon. Even though I have the device tunnel and the certificate there, the device tunnel won't light, it won't start because it's still pro. So I worked with some of my friends in the systems management field to kind of come up with a workaround for that. Shout out to Mike Niehaus, John Markham, Sandy Zhang. There's a couple of other folks who helped me out, but ultimately, and Mike Niehaus was one who kind of got me started on this. But basically, he told me that what he does is he puts there's a uh, there's a KMS activation key that's kind of a well-known or universal key. And so what you have to do is input that, get it to Enterprise Edition, and then you can support the first logon. But then later you have to remove that key, put the Pro key back in, activate it, and then step up upgrade will work. Um, Not trivial, not something I would recommend to anyone. I do have a script. It's available in my GitHub that will do all of that stuff for you. Uh, but your best bet is to avoid it and go in native intro join and forget it all. So don't worry about it. But anyway, it can be really, really challenging if you go that route. Finally, wrapping things up, I want to talk about global secure access, because this is a new solution from Microsoft. It's gaining some traction as we speak. It just came out year and a half or so ago. Um, but in terms of technologies, it's still fairly new, especially in the Microsoft space. So I have not seen a lot of adoption. This I expect to ramp up heavy next year, in the next few years. But right now, it's missing a couple of features that I think are still crucial. Those are coming, but I think it's going to be a really good one. But Global Secure Access is Microsoft's Security Service Edge, or SSE, solution. So it is basically a cloud-based um, private network gateway. And so with Global Secure Access, by the way, Global Secure Access entails a couple of different things. It is two components, two major components, which is intra-internet access, which is a cloud-based secure web gateway. Again, think Zscaler, Netscope, those types of solutions. But it also includes intra-private access, which is a zero trust network access solution. And so what you can do is when you install the GSA client, uh, one client gets you all of that. So you can control access to the internet. I can do traffic filtering and monitoring, content inspection. I can do all the reporting capabilities, basically an internet filter, right? But I also get inter-private access, and inter-private access is compelling because it is a completely cloud-based, nearly completely cloud-based solution to provide access like VPN-like access, but without a VPN. I will install, all you have to do is install a connector on premises, and that connector talks outbound only. And in fact, if anybody's familiar with the old Azure application proxy, actually, it's now called Intra Private Network Connector is what it's called now. But basically, the old Azure application proxy allowed you to publish on-premises web-based applications to the internet without having to do like open any firewalls or do any load balancers or anything like that. The Inter-Private Network Connector is the Azure application proxy that has been updated to support TCP and UDP-based applications. So now, whereas before I could only get to web-based applications, now I can get to things like SMB file shares, RDP servers. I can get to routers and switches via SSH, all sorts of things that you can do with it over and above just web-based applications. So in addition to web-based applications, it's really compelling today. Today, there's an agent that you install on Windows. The Global Secure Access Client gets installed on Windows. Microsoft has stated that in the future, they will bake the GSA client into Windows. So you won't even have to install something. It would literally be some settings in Intune that you'll adjust, or actually, technically, it's Entra. You'll do that in Entra. And install the connector to establish that physical connectivity between your resources and the cloud. And at that point, it's just about creating policies. And I can just create a policy and allow traffic. And the beauty about it is that it is very identity centric. So it integrates with Entra ID, supports conditional access. So I can put conditional access policy. So I can actually enforce multi-factor authentication to like an SSH port on my router or something like that, or switch or what have you. And of course, conditional access policies, you can do all the goodness that you get with that, right? So I can do different types of authentication levels, different types of restrictions based on location, risk, sign-in risk, all the good stuff you get with Entra conditional access. You can apply to your secure remote access solution. And again, zero infrastructure other than that one connector you have to install. All done in policy and Entra and Intune. All completely zero trust. The client does not have a routable IP address on your network. It's not a VPN adapter. It's something. It's basically implemented as a filter driver in Windows. It basically intercepts traffic and just says, "Oh, this is going to go over the tunnel to the Entra cloud. Entra cloud routes it over your connector, and then you have access to." And of course, applies conditional access and authentication and stuff. And at that point, you're connected securely. I've been using it. I've been using Entra conditional or Entra private access now for close to 3 years because I was blessed. I was very fortunate to be involved in the private preview. So I got the first kind of private look outside of Microsoft for the solution. So I've been using it quite some time. It was real challenging because I was super excited about it and couldn't talk about it for nearly 2 years. But it's a phenomenal solution. I think it's one that's going to be really compelling. They're still kind of ironing out some of the bugs, but it has gotten a lot better since it was first introduced. It is going to get better. There's some new capabilities coming later this year that I think are going to finalize some of the things that I think are missing from it. And I think going forward next year, I think you're going to see a lot of movement towards that. It is much, much simpler and easier to implement and support even than always on VPN. No on-premises infrastructure, no certificates, no dealing with routing. It's gonna be fantastic. It's gonna be a really, really good solution. So that being said, that brings me to the end of my session here. My 2 hours are up. Thank you, Johan, for having me again. I'll open it up to the floor if there's any other questions about anything else at all. Happy to answer those. Otherwise, I will leave you with my connection, my internet footprint, as it will. Go to richardhicks.com/connect. There's links to all of my stuff there. I'm on, I keep wanting to call it Twitter. I'm on X and LinkedIn and Facebook and all the good stuff. So there's links to everything there if you just go to richardhicks.com/connect. But if you have questions at all, I would appreciate it. And if not, we can call it a day. Your call. Anyone have any questions at all?
No questions at the second, but thank you so much, Richard.
Yeah,
Stellar presentations as always.
you bet. Thanks for having me.
Oh, of course. Absolute
Looking forward to
pleasure.
the next one already.
Yeah, exactly. Exactly. But I do not see any other questions in the queue here, other than a lot of thanks, of course.
Yeah, thank you, everybody.
So we are going to wrap up the training for today. And we see you back tomorrow morning for the grand final. It's going to be a lot of troubleshooting, but also some other fun stuff. So until then, have a fantastic night, evening, morning, depending on where you are in the world. And see you then. Thank you.
Yeah. Cheers, everybody. Thanks.
Thanks, everyone.